Hi, I'm Matt Choi, and today we're going to be talking about remainders. You remember remainders, right? Remainders. We haven't touched this since we were in elementary school. At some point during elementary school or middle school or maybe even high school, teachers told you not to use remainders anymore. When you're dividing, they tell you to divide all the way now. You divide all the way into the decimals. But if you try to remember, back then, a long time ago, we used to leave remainders. What were they? Basically, you divide something into a number as many times as you can until you can't anymore, and then what you have left is what you call the remainder. Okay? Now, the SAT actually brings this back sometimes in some problems. They give you problems like this one. They say, when the number x is divided by 9, the remainder is 3. What is one possible value of x? Of course, as you can see, they don't give you problems like you might be used to from elementary school. They make it a little bit harder because they don't give you what number you're dividing and they don't give you what the result is. All they tell you is what it's divided by and what the remainder was. So basically you have this situation. You have x divided by 9 equals something with the remainder of 3. You don't know what that something is, you don't know what number you started with, but that's alright. So what you do is basically, if you're trying to figure out one possible number that you could have started out with, you just add the remainder to the number that you divided by. So you get 3 plus 9, which is 12. And 12 happens to be a possible number for the number that you started with. And we can check it right now. So let's try number 12. If you try 12 and you divide by 9, what happens? You put it one time down, and you get 9 here, you get a remainder of 3. So yeah, it works. So it fits what they just told you, so this is one possible answer. And that's pretty much all there is to it, except for one more thing, which is that if you're trying to find out other numbers that you could have started out with, all you have to do is keep adding 9. Okay? For some problems you will have to do that. So let's take a look and try it out on a problem. It says positive integer m divided by 9 gives a remainder of 4. And I'm going to translate that right now. So m divided by 9 gives you a remainder of 4. What is the remainder when m minus 3 is divided by 9? Okay, this is a very easy problem. All you have to do is figure out what m can be, and then just do m minus 3 after that. So let's just try this one. So let's see, what could m be? What did I tell you to do? Just add this one to this one. So you have 13. Because 4 plus 9 is 13. And that's what m could be. Okay? And if you do m minus 3, that's obviously 10. All you have to do is figure out what the remainder is when you divide 10 by 9. It doesn't matter what it is, it gives you a remainder of 1. Okay? And that's your answer. That's all there is to it. It's very easy. Okay, let's try another problem. When positive integer j is divided by 13, the remainder is 5. What is the remainder when j is divided by 4? Okay, same thing. Just set it up. So j divided by 13 gives you something with the remainder of 5. So you just add 13 and 5 to get 18. So j can be 18. Okay, and then what's the remainder when 18 is divided by 4? Okay, you don't care what the result is, but 4 would go in there 4 times to give you 16. Then it would give you a remainder of 2. Okay, that's it. Not very hard. Okay, let's see if it gets a little harder. Yes, it does. When positive integer x is divided by 12, the remainder is 4. Okay, that means x could be 16, right? Based on what we did so far. But look what it says. It says if x is a multiple of 13. Is 16 a multiple of 13? It's not. So we have to look for a different answer. So x cannot be 16. But like I said before, if you're looking for numbers bigger than that, all you have to do is keep adding the number you divided by. So just keep adding 12. So if you add 12 to 16, that gives you what? That gives you 28. If you add 12 on top of that, you get 40. And you're still not at a multiple of 13. Try adding 12 again, you get 52. And 52 actually happens to be a multiple of 13. It goes in there 4 times. So that is our answer, and that's pretty much it. So that's as hard as remainder problems get. If you have any trouble with it, you can always try actually dividing it out, or you can try different numbers. But really the key here is the shortcut that I taught you, which is to add the remainder to the number that you divided by. And you should get one of the possible numbers you could have started with right away. And if that doesn't work, you just keep adding what you divided by on top of it until it satisfies whatever condition the problem gives you. And that's pretty much it. Okay, so I hope this helps you out on some remainder problems, and I hope you learned a lot. Alright, thanks for being with me.